Hello and welcome. Have you ever heard of scientists identifying chemicals by their unique molecular fingerprint? That's the magic of infrared, or IR, spectroscopy. But you might also hear the term FTIR spectroscopy, and it can be confusing. Are they the same thing? Well, yes and no. Today, we're going to break down the key difference between traditional IR and modern FTIR spectroscopy in a simple way. The core idea they both share is shining infrared light on a sample to see which frequencies of light are absorbed by the chemical bonds, causing them to stretch and bend. This absorption pattern creates a unique spectrum, a graph that acts like a fingerprint for that molecule. The real difference lies not in what they measure, but in how they measure it. Think of traditional, or dispersive, IR spectroscopy like listening to a song one note at a time. The instrument uses a device like a prism or a grating to separate the infrared light into its individual frequencies. It then sends one frequency at a time through the sample, measures the absorption, moves to the next frequency, measures again, and so on. This process is very slow, often taking several minutes to scan the entire range, and the signal can be quite weak because you're only looking at a tiny slice of the light at any given moment. Now, let's talk about FTIR, which stands for Fourier Transform Infrared Spectroscopy. This is the modern, powerful method. Instead of playing one note at a time, FTIR is like hearing the entire musical chord at once. It uses a clever device called an interferometer, which takes the entire beam of IR light, with all its frequencies, and passes it through the sample simultaneously. This creates a very complex signal called an interferogram. This jumbled-up signal contains all the absorption information from all the frequencies mixed together. Then, a computer performs a rapid mathematical calculation called a Fourier Transform. This calculation is the magic trick that instantly unscrambles the complex interferogram and converts it into the familiar, easy-to-read spectrum. So, why is this better? FTIR has huge advantages. First, it's incredibly fast, collecting a full scan in a matter of seconds. This speed allows us to take many scans and average them together, which dramatically reduces random noise and gives us a much cleaner, clearer spectrum. Second, it's far more sensitive because much more light energy reaches the detector at once, resulting in a stronger signal. This means we can analyze very small or weakly absorbing samples that would be impossible with old dispersive IR. In summary, while both techniques give you a molecular fingerprint, dispersive IR does it slowly, one frequency at a time, while FTIR does it rapidly, all frequencies at once, using an interferometer and a powerful math trick. This makes FTIR the standard in virtually every modern lab due to its superior speed, sensitivity, and accuracy. Thank you so much for watching. I hope this cleared up the difference between IR and FTIR for you. If you found this video helpful and learned something new, please consider giving it a thumbs up and subscribing to the channel. Your support helps me create more content just like this. See you in the next video.